Predicting an exact answer to the questions we ask can be a difficult task. More often than not, we are more curious about the range in which our answer lies. Thankfully, statistics allows us to do this through confidence intervals. Imagine trying to guess the weight of an African lion without getting too close. You might not guess the exact weight, but watching enough of the National Geographic channel will probably lead you to be pretty sure it's between 150 and 250 kilograms. This range is essentially a confidence interval. It gives us a safe range in which our answer is likely to be. When working with data, we often come up with a single number that best describes our sample, like a mean or a coefficient. But what if we were to take another sample? Would this number change? Possibly, and that's the uncertainty we face in statistics. Confidence intervals acknowledge this uncertainty. Instead of giving one exact number, they provide a range within which the true population parameter likely resides. Confidence intervals are a safety net against randomness. In my previous video, we looked at an example situation about the effect of marriage on wages and hypothesis testing. From this example, here's another code I made in Wolfram Mathematica to delve further into confidence intervals. It may be a bit lengthy, but it thoroughly demonstrates the concept. Here, you will notice the OLS estimate, which represents our best guess for the effect of marriage on wages as a point estimate, the standard error, which gives us an idea about how this estimate might change with different samples, and the confidence level, which tells us how confident we are that the true parameter lies within our interval. We construct a confidence interval by finding the lower bound and the upper bound. The lower bound is equal to the OLS coefficient estimate minus the critical value given the sample's degrees of freedom and the significance level, which is 1 minus the confidence level and all divided by 2 times the standard error of the OLS estimate. The upper bound is the same calculation, except this minus becomes a plus. Therefore, with a certain level of confidence as a percentage, the confidence interval tells us where we believe the true effect of marriage on wages lies in the population. A 95% confidence interval does not mean that the true parameter has a 95% chance of lying within the range. Instead, it means that if we were to sample over and over again, we expect about 95% of our constructed intervals to contain the true parameter. So, if our interval for the effect of marriage on wages is 1.00977 to 1.99023, we are suggesting that we are 95% sure that the true effect of marriage on wages is somewhere between that range for an increase, while considering other factors constant. For more insights into the meaning of terms like test statistic, critical value, and significance level, I highly recommend checking out my previous video on hypothesis testing. I hope you enjoy it. The beautiful plot in the code visually represents our confidence interval. The blue dot is our OLS estimate, the red shaded area represents the confidence interval, and the curve represents the distribution of our estimate. This visual representation shows how our estimate stacks up against what we might expect purely by chance, and how confident we are in this estimate. By using these sliders, you can see how the confidence interval stretches as the confidence level increases and how it contracts as the confidence level decreases. You will also notice that larger standard errors contribute to more uncertainty, thus stretching the confidence interval. But smaller standard errors give us less uncertainty, thus contracting the confidence interval. And you can do this for many coefficient possibilities of the OLS estimate. To explore independently and gain further insights, you can use this code on my website through the link in the video description below. We can always increase our confidence level, but that would also make our interval wider, giving us less precision. Similarly, a smaller interval might give us more precision, but less confidence. In statistics, we often have to decide what we value more, precision or confidence. But it's not just about crunching numbers, it's about understanding uncertainty, making informed decisions, and telling stories with data. Confidence intervals are just another chapter in this fascinating story.